Okay, so far we have covered the first module, second module of this machine learning, that is the subject code BCS602, 6th semester VTU syllabus. In this video we are discussing about the module 3 of the important concepts and the topics along with the numerical problems. Okay, so it covered the entire module overview. Okay, let's start one by one. So in this module 3, there are 3 chapters: similar based learning, regression analysis, decision tree learning. So in the similar based learning, we can see the numerical problems. Okay, so k nearest neighbor learning is there, weighted k nearest neighbor algorithm, then nearest centroid classifier, locally weighted regression. These are all 4 part are having a numerical problems in the first chapter. Okay, in the second chapter it is little bit theory as well as numerical problems are there. So introduction to the regression, introduction to linear regression, multiple linear regression, polynomial regression, logistic regression. And in the chapter 3 decision tree learning, there is a almost all theory is there, that is a introduction to decision tree learning model, decision tree induction algorithms. Here 3 algorithms are there, and those are also having a numerical problems. Okay, let's start one by one. So the first one is you know uh, k nearest neighbor learning. So here k nearest neighbor learning algorithm is there. No need to read this algorithm, so no need to by heart this algorithm, guys. When you start to solving the problem, no, then you will understand the algorithm, how it is. Okay, let's start with the problem itself. Okay, for the k nearest neighbor algorithm, consider the student performance of a 8 instance show in the table. So this is the data table they have given, then which describes the performance of the individual students in the course wide their CGPA obtained in the previous semester. Based on the performance of the students, classify the students whether he will pass or fail in that post with the given test instances. These, so they have given one student, data training data table. So this is a table, from this only up to this table is there. When you start solving this problem, no, you need to again draw this entire table, and you need to add the one extra column, that is a Euclidean distance. So because you need to find the Euclidean distance here, that's why up to till result it will be there in the question paper, table. Further you need to add this extra one column, then starts with the solution. Let's first one is you need to find out the Euclidean distance of the CGPA. So with the given instances, that is a see here instances are given, you need to consider those are x1, x2 and x3. And again see, in each row this is the x2, y2, z2. Okay, this is x2, y2, z2, and here it is a x1, this is a y1, and it is a z z1. Okay, uh, yeah. And the Euclidean distance formula is x1 this is x1 comma x y1, x2 comma y2, x3 comma y3 is equals to root of x2 minus x1 whole square, y2 minus y1 whole square, z2 minus z1. You just need to simplify with this this c 9.2 minus 6.1, here I have written, whole square. Again 85 minus 40, I have written here, whole square. Then 8 minus 5 whole square, I have written 8 minus 5 whole square, that is whole root. So when you solve this, you will get a 45.20. You need to write in the Euclidean distance like that. Don't enter all these values in the solving manually. You just go through the calci and you just find out the solution. You need just Euclidean distance value. That's why I have, for the reference purpose, I have written for the first one Euclidean distance. Like that, you need to find the 8 minus 8 minus 6.1, 80 minus 40 whole square, then 7 minus 5 whole square. You will get a Euclidean distance. Like that, you need to find the Euclidean distance. Then step 2, what you need to do, whatever the Euclidean distance you got, no, based on that you need to arrange the lowest wise. See here, 5 is wait, yeah, here see 5, 10, then very lowest value, I think it is a 20, right? 7. Oh, see, it is a 2. 2.0 is there. It is a point, okay? 2, 32. Here I have arranged this Euclidean value itself as a lower to higher wise. So here it is low value is there, and further high values are there. And starting 3 you need to consider as a k nearest. So this 745 instances. So number, serial number 745, you need to take a separate and write the with that row distance and results. Here that row, see, 2 row 5.2, it's distance, and result, what the result it is, you need to write that instance, Euclidean distance and result. Then you need to in the k nearest neighbor, you just find the based on the result which is higher. For example, see here all threes are fail, so the result is you will get a fail itself. If two are a pass and one is fail, majority passes are there, so the result will be pass. So based on that you need to perform. It is a very simple question, simple problem is there, k nearest neighbor. Let's see the next one, k nearest, weighted k nearest. So this is a weighted k nearest algorithm. As like a k nearest algorithm itself, you need to find same Euclidean. So this is the example. um, I just said I will just say that what you should do in the weighted k nearest neighbor. As like only k nearest neighbor, you need to do the procedure Euclidean distance. You need to find out. Then you need to find out the three k nearest values along with the classes fail, pass, fail. Then here in the step 3, in the k nearest label, we based on the majority will give the conclusion. But here you need to find the inverse of the Euclidean distance. So Euclidean distance you have already got. You need to take a inverse of this Euclidean distance, that is 1 by 15.30. You will get this value. Like that only you have to do the further two. Again you need to write the fail. After once you got all the inverse value of distance, no, you have to do the sum of the inverse of distance. So find the sum of inverse and you will get a sum of the value. So after when you got the sum value, no, then you need to divide this inverse divided by sum, that is called as a weight. So you need to find the weight. So weight is equals to inverse is already there, which is you have taken here. Yeah, here inverse value is there. So each inverse value divided by whole sum. For let's take a 0.06502 divided by 0.2403, like that. So once you do know, you will get another value, that is a weight value. Okay, based on that weight, based on the classes, you need to add a value. See here, two fails are there, one pass is there. Add these two and we'll see the 6 you know 6 0.65 something, and pass value is 0.3, because it is only one value is there. So then you need to compare here which one is higher. So here fail is having a high value, that's why the conclusion, the result will be fail. That is the answer. This is all about a k nearest and weighted k nearest. Like that only next nearest centroid algorithm is there. Here in the nearest centroid algorithm, it is also very short, short and time reducing problem is there. You just go through this. Okay, see, let's directly get into the problem. Consider the sample that data with the two features x and y. The target classes are a and b. Predict the test case classes using the nearest centroid algorithm. Test cases x, y is there and classes is there. Firstly, you need to find the mean of the A classes. Wherever A is there, this is A, this is A, and this is A. You need to find the each mean. So mean 3 plus 5 plus 4. I have written here 3 plus 5 plus 4. So divided by 3, because classes A class total A classes are 3. So divided by 3, like that y 1 plus 2 plus 3 divided by 3. So once you solve now, you will get a 4 comma 2 value, that is a centroid mean of class A. Okay, similarly you need to find out the centroid mean class of B, that is a where these 1 2 3 7 plus 6 plus 8 divided by 3, 6 plus 7 plus 5 divided by 3, here I have written, then we'll get a 7 comma 6. Once you get a, once you got these two values, no, centered mean class of A and B, then you need to compute the distance between instances. So for that, for you need to do the this distance, A and B distance you need to find. See, here it is a x1 and it is a x2. Okay, and similarly this is a y x, this is beta, yeah, it is x1, this is x1, this is a y1, this is a x2, this is a y2, and the simplify Euclidean distance, that is a 6 minus 2 comma 5. Okay, okay, they have given, right? Yeah, test instance they have given here 6 comma 5. You need to take this as a x2, x2 x2 x1 y1 and x2 y2 here. See, then 6 minus 4 whole square, 5 minus 2 whole square, that is x2 minus x1 whole square, y2 minus y1. That formula, you when you apply now Euclidean distance, you will get this value. Again, same Euclidean distance for the B. By using this test instances, you need to find the for Euclidean distance for A and B. Then you need to find, you need to analyze that which one is nearest. So here B value is very low value, so that's why the test instance for a 6 comma 5 nearest to the B, so it is predicted as a class B. This is the thing for a some nearest centered algorithm. Then comes a local weighted regression. Here you need to find out the local weighted regression. It is also little bit it is very easy, guys, but as you if you remember these formulas, here you need to find out the a naught and a, this is a naught and it is a a1. You need to find out this a naught and a, then directly simply you need to insert here y equals to, and oh sorry, so a naught value, then a1 value, when you insert no, then when you will get a equation y equals to a2 a1 local weighted regression. That is why I will explain this concept in next regression. There also one numerical problem is there like that only. So you just remember this formula and solve one problem. Okay, so by explaining it will get a little bit confusing. You just go through this PDF and you will understand. Okay. Then moving on to the regression analysis is there. So it is a theory plus uh, problems are there. So regression analysis is nothing but a it is a model recap, relation between a two or more independent variable and one dependent variable. So it uses the supervised learning method used to predict continuous values. Okay. Here you will see primary concern of regression and all the theory part is there. You just go through this PDF. Introduction to linear correlation. Yeah, here first one is regression correlation. Again, some dependent variable and y dependent variable in the correlation is there. Positive type correlation, negative type. Whenever the x increases, then y will also increases in the positive, whereas in the negative, wherever x decreases, then y will also decrease, like that. again random number of numbers with the no relation. There's a, like there is no any relation between number points, there is no any connection, that is the thing. Okay, so then regression is predicting one variable given another variable. Theory is there, it is all theory. Then comes a classification of regression model. The regression model method classified into three types: linear, non-linear regression model, and logical regression. Okay, again in the linear regression model, we can see the single linear regression and multiple linear regression. Okay, in the non-linear regression, you will get a polynomial regression type. Okay, then let's see the types of regression. It is a important topic because there is a chance of appearing this. Explain the types of regression. First one is linear regression. So linear regression is a linear relationship between a one dependent and one independent variable. See, x and y graph you saw no previous. That is what. So when x sometime x is dependent, y is independent, like that. So whenever x increases, y will also increases. So y is the dependent of x. So sorry, x is a dependent and y is independent, like that. What, however you take the relation, like that will goes in the linear way. So multiple regression, it is a relationship between a more than one independent variables and a one dependent variables. Then polynomial regression, it is a nth degree of a polynomial used to model a relationship between the two or more independent variables and one dependent variables. Fourth one, logistic regression, used to predict the categorical value and also used to find the relationship between a two or more independent variable, one dependent variable. That is the thing. And fifth one, the lasso and ridge regression method is also there. Okay, you just go through that. Then linear regression. First one, linear regression. Okay, so here problem is there. So linear regression represented like this: y is equal to a naught plus a1x plus e, where a naught is a intercept represent bias, and a1 is a slope. Then e is a error prediction. Okay, that's all. Again, as I already told you, no, a naught and a1 you need to find. Then you need to apply in the this linear value. Okay, see, let's see the problem. Linear regression: consider an example where the 5 weeks sales data in thousands in a given below. Apply linear regression technique 7th and 9th month. Here they only give this table. So for whatever you need values, no, to find the a naught and a naught and a1, you need to find. So we need a xy bar, x bar, y bar, xi square, then x bar square. Let's see the x bar. X bar is a mean of this x value. You need to add this all 5 plus divided by 5 you need to do. You will get a x bar. Like that you need to do the y bar. Then x bar, xi bar whole square. Xi bar whole square is nothing but a whole xi weeks. Okay, so here xi is a here, see, the square of xi. So it is a xi square. Okay, um yeah, xi square, 1 square, 2 square, 3 square, 4 square, and 5 square here written. And xy bar is nothing but a, you need to find out the first x and y multiplication, then like 1 into 1.2, like that. Then you need to find the sum of xy, then divided by 5 you need to do, then you will get this value. So once you all find the values, no, you just insert in the in a1 value and a naught value. A1 and a naught formula, it is a, you know, a1 formula, and here a naught is there. When you insert now, you will get a a1 value, then a naught value. Then simply in a1 value and a naught value you need to add in this um, where equation here, y equals to a naught. That is, here I have written y is equals to a naught value is 0.54 plus 0.66x. That is what, again, linear regression matrix form is there. This is also one numerical problem. This equation is important. You just go through this PDF. Again, problem is there. Here in this module 4, almost all it covered with the numerical problems itself. Okay, so you just go through this problem as well. It is a simple, see, x and y is there dependent variable. You need to take a x transpose. So x 2 3 4. When you get a x, x is a dependent variable. Okay, so here you need to do the in this form 1 x1 x2 x3. Wherever x will be there, you need to add with the 1 because it is a dependent. Y is a independent. So here x transpose x transpose x will be written as a 1 1 1 1 2 1 3 1 4 like that. One, then you need to take this x transpose, that is a one row will become a column, column will become a row. Here x transpose you multiplied with this x value. So when you do this procedure, you will get a x transpose, xt x and x transpose and x you will get. Then again you need to take this transpose because this is the formula. Okay, so you need to remember this formula, and why you are doing this, you are finding this value x transpose and x. So once you get this x transpose and x transpose, no, x transpose and x and whole transpose. So here one standard formula is there. If the matrix transposer, you just apply here, this is a, this is a b, this is a c, this is a d, and 1 divided by ad is nothing but a 4 4 into 30, 4 30 is a 120, then 10 tens are 100, 120 divided by 100, and again write this as it is with the changing uh, characters. See, a b c d, when you named it as a b c d, just replace according to this formula and you solve. So you will get a transpose of this value, you will get a transpose. Then simply add those values in the formula and find the a value. So here in first value is, it is a interrupt and it is a slope. This is the thing. Then moving on to the finally decision tree learning is there, and it is also a theory is there. Decision tree is a concept tree which summarizes the information contained in the training data. Okay, and here again theory is there. Mainly the question is the structure of decision tree. Yeah, this question there in the question paper. Structure of decision tree, a tree is a um, hierarchical model used for the classification or a regression. Its structure includes the root node, decision node, and leaf node. Okay, so explain each diagram. Then advantages of trees are there, disadvantages of trees is list is there. Then moving on to the lastly decision tree induction algorithm. Here three problems are there: id3 construction, c45 construction, then c cart construction, that is a classification and regression tree construction. Here problems are solved. I think, yeah, for the id3 construction, this question has appeared in the question paper. It is solved over here. You just go through this pdf and practice on your own. Okay, so if you need a solving by manually, let me comment below. Okay, I will start one by one problem solving video. So while solving the problem, you will also understand and you people will also uh, able to solve that. Okay, that's it. And guys, I will add this pdf in the description box. um, you can refer this pdf. Okay, so yeah, uh, within a couple of minutes I will add once I have posted this video in the YouTube. That's it all about the module 3 of machine learning. Thank you guys.